Our next strategy for solving rational equations involves pulling out an old ability that we had back when we solved proportions, which is cross multiplication. Cross multiplication as a strategy will be useful in any time you have, in any situation, and any time you have a fraction equal to another fraction. Now, this limits us for rational equations because rational equations can have other terms in them, potentially the sum of two rational expressions, maybe a constant added to the end of one of the rational expressions. So it's not the best strategy, but certainly when you see it and you run into an opportunity to use it, cross multiplication is a very simple alternative to looking for the common denominator, especially in a situation like this where the least common denominator would be this factor times this factor, which might create a lot of extra multiplications that we don't really need to worry about. So cross multiplication says numerator times the denominator and numerator times the denominator. Our first multiplication gives us negative x squared plus 27. That's negative 1 times x squared minus 27. And the second one gives x minus 3 times x minus 4. The presence of this x squared, again, tells me that I want to push everything to one side. I'm going to try to factor at the end, and I'm going to try to solve the small equations using the zero product property. So we have negative x squared plus 27. This becomes x squared minus 7x plus 12. And push all those terms over. We get negative 2x squared plus 7x plus 15 is equal to 0. Now, the strategies that we have for factoring leave a little to be desired when this initial term is negative. Fortunately for us, again, because of the presence of the equal 0, dividing everything by negative 1 is not going to change our equation, to change the solutions of our equation. It's going to make the equation look a little different, but dividing by negative 1 serves the intention of getting that lead term to be positive, but not wildly changing the equation that we're going to solve. Now here we have a little bit of factoring, a little bit of creative factoring that we need to do in order to figure out our two factors that are going to multiply together to make 0. And a little bit of trial and error, a little bit of AC method. We should get 2x plus 3 and x minus 5. Meaning we have two solutions, x is equal to negative 1.5 and x is equal to 5. We try both of those answers in the original expression. We can see on a quick check that they're both going to work, but detailed substitution, checking all of the values, you should get that both of these numbers are solutions to that rational equation. Now, in the event that you have something that's not written as a fraction equal to another fraction, you have the luxury or the option to try to write it so it is. This is an example that we looked at in a previous video where we saw that it had the two solutions, x is equal to 15 and x is equal to 1. This is not initially a candidate for cross multiplication. The presence of the 1 and the minus sign mean that we do not have the situation of a rational expression equal to another rational expression. However, if we rewrite the first fraction as x minus 5 over x minus 5, which again we remind ourselves has a value of 1, we can look at that left-hand side and say, oh, those two rational expressions have the same common denominator. Why can't we just add them, or in this case, subtract them, and create one fraction? We could do that. So let's subtract x minus 5 minus 8 and put these two fractions together, giving us x minus 13 over x minus 5 is equal to 3 over x. Now that it's a rational expression equal to another rational expression, we can cross multiply. We get x squared minus 13x is equal to 3x minus 15. We move our terms all over to one side thanks to the x squared. We factor one more time, and we get our same two solutions. So cross multiplication is an option in those situations where you don't have a fraction or a rational expression equal to another one. You can use it You just have to make sure that you're careful in your use of common denominators to combine the terms together in the correct way. And that's exactly what we did right here. We rewrote 1 as x minus 5 over x minus 5, and then combined those two together in the appropriate way. I'm still looking at this as the goal. This is the situation where we really want to look for cross multiplication. You can have an argument with someone over the fact that this is not that much simpler than just multiplying by the common denominator for the whole expression. And that's a valid argument. This might create, depending on the situation, this might be way more work than just going through the other path. But if you have a fraction equal to another fraction, then cross multiplication is definitely going to be quicker, and in a lot of cases lead to simpler factoring and simpler work that needs to be done.